Hello, my name is Benson Long. I am a student at the University of New Mexico and a junior in the Civil Engineering Department with an interest in transportation engineering. Today I will be presenting my poster of spatial equity analysis in nighttime pedestrian safety and their roles in land use and alcohol establishment. This is the general design of my poster and will present each part individually. Over the past decade, the United States has experienced a 53% increase in pedestrian-related fatalities, with 2018 having a 3% increase from 2017. With 76% of these pedestrian fatalities occurring at night and 50% occurring during peak hours of activity between 6 p.m. and 11:59 p.m., this is actually very concerning, as you can see from the graph to the left. Prior research has statistically correlated pedestrian safety and nighttime lighting conditions, but very little has explored spatial analysis into these two factors. The purpose of this research is to determine spatial analysis in GIS to identify associations between lighting conditions, land use, socioeconomics, and fatal/severe pedestrian crashes. We hypothesize elevated levels of pedestrian fatalities and severe injury clustering near alcohol establishments during nighttime lighting conditions. To better obtain our objectives, data was used from Albuquerque, New Mexico between 2013 and 2018. Data was collected by uniformed officers using a uniform crash report with coded tracking numbers to ensure consistent data collection. Data was then broken down according to three subdivisions: crash level, vehicle level, and occupant level. The data was then allocated according to land use attributes and labeled according to business function. An example of this is the difference between restaurant and bar establishments. In a restaurant establishment, food and alcohol would be the two primary goods in which a customer can receive. In a bar setting, alcohol would be the only good that a customer can receive. A population-based exposure served as a proxy and was derived according to the 2017 ACS guidelines. Furthermore, we use buffering grouping of four subdivisions: fatal injury during daytime, fatal injury during nighttime, severe injury during daytime, and severe injury during nighttime. As for statistical analysis, we converted the number of crashes into a prevalent per 10,000 people. We also used the tool in GIS to derive a z-score and compared it according to a 95% confidence level. The experimental equations seen here are for the crashes per 10,000 people and the statistical analysis tool seen inside of GIS. Here we display several tables showcasing the results of the study. These findings suggest that alcohol establishments did have a high risk of producing pedestrian crashes. This is seen in Table 1 when we compare alcohol establishments to restaurants. We can consistently see that there is a high level of pedestrian crashes. This is supported when we look at commercial settings when compared to residential settings. In the rest of the tables, alcohol establishments consistently show a high confidence in each category, both light and dark, and white and non-white areas. Findings also suggest that predominantly non-white areas of Albuquerque produce high levels of pedestrian crashes. All the findings show that nighttime lighting conditions show elevated levels of pedestrian crashes. These results show that there is a support of the hypothesis that elevated levels of pedestrian crashes do occur near alcohol establishments and nighttime lighting conditions. Now that we see the results of the statistical analysis, we can look at a spatial analysis of Albuquerque inside GIS. When we plotted these values in GIS, we did see a clustering of pedestrian crashes in the western portion of Albuquerque and high levels correlated along the Coors Boulevard road. This road is consistently higher in volume and much more wider in width. Another interesting thing that we found was that lower levels of pedestrian crashes were centered around downtown area. This may be due to the lower speeds and the much smaller width. We look at these areas and we want to consider that road design may be a factor in terms of pedestrian crashes, but further work may be needed to support that hypothesis. In summary, results did support the hypothesis that pedestrian crashes, both fatal and severe, were factors of land use, nighttime related lighting conditions, and alcohol establishments. Rates were also higher in non-white neighborhoods, but seemed to be well distributed throughout the city. Nighttime fatalities were also widespread, but did see a higher clustering in the western portion of Albuquerque. These areas may be an interest due to the design of roads which are typically wider and see higher levels of traffic. Future studies may be able to target these re-examinations of road designs. Other future works may help us look into alcohol being consumed on the premises, or if it was more of a drink and drive situation or a combination of both. We can also see for work that there would be a re-examination of land use topics as to why alcohol establishments would see a higher rate during the day rather than at night. We could also see future work into concentrating on specific corridors rather than looking at Albuquerque as a whole. I would like to take this time to give my thanks to the National Science Foundation, the Transportation Research Board, and the Alliance for Minority Participation for funding this research. I would also like to give a special thanks to Dr. Nicholas Ferenchek for his support in guiding me and helping me in this research project and giving me the leadership and mentorship that inspired me to follow a transportation interest. I would also like to give a special thanks to my supporters, collaborators, and family for their continued support throughout this opportunity. Thank you, and I hope you have a wonderful day.